Welcome back, guys. Today we'll be doing January 2021 CSEC Mathematics Question 9B. It's a bearings question. The question states from a harbor H, this is a harbor H, the bearing of two buoys S and Q, S and Q. If you're wondering what is a buoy, it is a floating object anchored in a body of water to mark a channel. Remember, when you go to the beach, you're always seeing the marker to say don't pass that line. So that is considered to be buoy because it's a marker, it's floating in the water. You watch movies where you have seen a floating object in the water, that is considered to be a buoy. So we have the bearing of two buoys, S and Q, are 185 degrees and 311 degrees respectively. Q is 5.4 kilometers from H, while S is 3.5 kilometers from H. On the diagram below, which shows a sketch of this information, insert the value of the marked angle QHS. Now, I am going to insert the angle QHS, but I'm also going to insert more information. We were told that Q is 5.4 kilometers from H. So I know that this is 5.4 kilometers. Also, S is 3.5 kilometers from H. So we know that this line is 3.5 kilometers. So in other words, we have HQ is 5.4 kilometers and HS is 3.5 kilometers. Now, we need to mark the angle QHS, meaning I need this angle from a harbor H. And remember, when we're measuring the angle, we start from the north and go in a clockwise direction. So the bearing of the two buoys, S and Q, are 185 degrees. So that means from the north, going straight to S is 185 degrees. While it says Q is 311, says it from the north going straight around to this line is 311. So from here going straight around is considered to be 311 degrees. So if I need to find out this portion right here, remember I have that from the north to this line is 185. So it means when I add this portion, it will give me the 311. So in order to get the extra portion, I have to subtract 185 from 311 degrees. So when I subtract 185, because from here to here is 185. So when I subtract all of this portion from 311, I will be left with this portion right here. So it means subtracting this, I will get 126 degrees. So that means that this portion, so I can remove this diagram. So therefore, this portion is 126 degrees. And you can always test if you're correct because the sum of this must give us 311. So when you add 126 plus 185, you will get the 311 degrees. So the next question that we have, calculate QS, the distance between the two buoys. Now, this is QS. So we need to find the distance between these two buoys. Now we know QH and we know HS. We have the angle 126. Now we can label these sides. Looking at this, When you have the angle 126 degrees, capital H I'll represent as the angle. So the side facing angle H, we are going to label it as common H. So this is capital H, the angle, and the side facing it, I will label it as common H. So there will be an angle at capital S. So the side facing it, I will denote it as common S. Also, capital Q will represent an angle that will be here. So the side facing the angle, I will call it common Q. So rather than me writing QS, HS, because the side is really QS and this side is HS, and the next side you can say QH or HQ. Rather than writing that, I can also rewrite it where the angle facing this side, since this is capital H, I can label this as common H, and the angle capital S is facing this side, so I can call it common S, and for angle capital Q, I can label the side that is facing it common Q. Now, having this information, it means QS is H. That's what we're trying to find. We're trying to find out what is H. Look at the information that we have. We have an angle, two sides, and the angle is in between the two sides, and we need to find another side. When we need to find another side, we are going to use the cosine rule. We will denote the cosine rule as this. We will start with h squared. Usually I say to my students, the angle that we have here, it tells us where we're going to start. So if this is capital H, and capital H is the angle, then it means the formula is going to start with common H. So if the angle was at capital S, then our formula will start with common S. So since this is capital H, our formula is going to start with common H. So the cosine rule will be h squared is equal to, now you are going to have the two sides being squared, so it's going to be s squared plus q squared. So I have s squared plus q squared minus 2qs and cos of the angle that we have present, which is capital H. So that's how we derive our cosine rule. We are trying to find H, so we're going to leave it as it is. But we have S. S is 5.4, so I'm going to write 5.4 square. And then Q is 3.5, so I am going to write the 3.5 square minus 2 times Q again. Q is 3.5 and times S. S is 5.4. Cos the angle, so it's cos 126 degrees. Now let us do the square. We know the square of 5.4 square, 29.16. 3.5 square, that's 12.25. Now 2 times 3.5 times 5.4. So multiply this and then times it by cos 126. You're going to get negative. So all of this, leave the sign alone, just multiply all of this. So 2 times 3.5 times 5.4 times cos 126. You will get negative 22.218. Now we have two negatives, so we know that will change to a positive. So we can now add all of this. So 29.6 plus 12.25 plus 22.18. That will give us 63.628. Now remember, this is the value for h squared. So to find out what is h, I will have to square root both sides. Square root cancel the square, so h is equal to 7.98. So I've rounded it off to 2 decimal places because here, if we round it off to 1 decimal place, because what we have is 7.97 and other numbers behind this, 6, 7, and it continues. Rounding it off to 1 decimal place, it will become 8 because behind the 9 is a 7, so I round up. So this is going to be 8.0. So we could have used 8.0, but my decision is just to use 2 decimal places since the two sides we have a decimal point. 1 decimal point, I'm unable to get 1 decimal point. So choosing 2 decimal places, my answer is 7.98. The next question asks to calculate the bearing of S from Q. So we need to find out what is the bearing of S from Q. So it means that the starting point is Q. So in other words, if you don't like the word bearing, we're just saying we need to know the angle that S is from Q. So measure the angle. Now, in order to measure the angle, first I'm going to draw my North Pole. We need to measure the angle that is formed going in a clockwise direction from the North Pole going towards this line. So all of this represents the angle. So we're trying to calculate the bearing of S from Q. So the starting point is Q. So we want to know, starting at Q, what is the angle that is created here? Now, how are we going to find this angle? First thing that we're going to do is look at right here. As you can see, we know that from the North Pole to this line, it is 185 degrees. Now, if this is 185 degrees, we know that from the North Pole to the South Pole, from here to here will be 180. So we know angle on a straight line gives us 180. So it means this little portion represents 5 degrees. Also, we know that from the South Poles, because this is the South Pole, to the west, this is west. So let me just label these poles. This is west and this is south. We know that the angle that is created here should be 90 because these are 90 degrees that is formed. Now, if you're not seeing it, I can just, so what I'm saying is that here is the south and here is the west. We know that a 90 degrees angle is formed. So if this little portion is 5 degrees, then the remaining portion should be 85. So I'm able to note that right here is 85 degrees. Also, if this is 85, we can note that if right here is 85, because 85 plus 5 degrees should give us 90. And that will be 90 degrees between the west and the south pole. It forms a 90-degree angle. So that's why I'm able to say this is 85 and this is 5 to give me 90. From this line to the line that we have here, we know it's 126. So it means if I want to know the remaining portion, I will say 126 minus 85. So subtracting this, I will get 41 degrees. So it means from the west to this solid line that we have here is 41 degrees. Let me repeat. So we already established that from the north to the south pole is 180. And since we have on the diagram that from the north pole going straight to this line that I have here is 185. So it means this small portion is 5 degrees. Also, we know that the west and the south forms at 90 degrees. So if this is 5, then the remaining portion that is left should be 85 degrees. Because 85 plus 5, that's 90. So that also means that I can find this little portion because I have this to be 126, and I know that this small portion here is 85 degrees. So it means what is left will be 41. Now where this diagram is a replica of what we have here, it's just a cleaner version. So remember we established that here is 85 degrees. Since here is 5 and this is 85, it adds to give us 90. And then right here we have 41 degrees because all of this should add to give us 126. If you look carefully, we have a Z angle. This is a Z angle. Look carefully, there is a Z angle. That's why I drew this line. So you can see the Z angle that's formed here. So if this is 41, then right here is also 41 degrees. Also, you can look at it as these two lines are parallel and this is the transversal line. So we know that if this is 41, then this is also 41 because they're alternative angles. So this is an alternative interior angle. It is the same as this angle. So you can look at it as a Z angle. So if this is 41, then this will be 41. Or we can just look at it that these are two parallel lines and we have the transversal line. So if this is 41 degrees, then this is also 41 degrees. Now from the North Pole to the east, we know that this is 90 degrees because it forms at a 90-degree angle. So here we can see from the North Pole to the east, we have a 90 degrees, then this is 41. So what is left is this angle that we need to find. Now, just a reminder that we know that this line is 5.4, this line is 3.5, and we also know that this line is 7.98. We need to find out what is theta. To find out theta, we are going to rely on the angle. Remember the angle that is formed here is 126 degrees. Since I want an angle and I have three sides, I could use cosine rule. So don't think you can't use cosine rule. I can use cosine rule. However, because sine rule is way more friendlier for some students when they're finding angles, I am going to use the sine rule. We have three sides and we want to find an angle. We could use the cosine rule that could assist us in finding what is the angle. But what I can also use is sine rule because I have an angle, need another angle, and I have the sides. So this is what I'm going to do. I have this angle and I have this side. I have this 3.5, which is this side, and I need to find this angle. I have enough information to use sine rule because I have two sides and an angle, and I need to find an angle. Now, just to remind you my labeling, this will be side H and this will be side common Q. If you realize I didn't use the 5.4 because I don't have the angle for S, but I need to find the angle for Q. Remember, this is angle Q. So the side that's facing it is common Q. And this is angle H, which is 126. All of this is 126. So if you want, I could remove this just to ensure no confusion. So this will assist you better to see that this angle will is 126. So we have side H and angle H. So the sine rule will be side H over sine capital H is equal to side Q over sine capital Q. So what do I have? We know that side H is 7.98 kilometers, and we know that the angle H is sine 126. We also know that side Q is 3.5, and we are trying to find angle Q. So let's leave it as theta. Now this can be entered into your calculator. Just enter 7.98 divided by sine 126. So 7.98 divided by sine 126, that will give us 9.86 to do decimal place, is equal to 3.5 sine theta. First, I'm going to get rid of sine theta. So I'm going to multiply both sides by sine theta. So multiplying both sides by sine theta, this will cancel. So what I have is sine theta times 9.86. When I have it side by side, it means I'm multiplying, is equal to 3.5. Then I divide both sides by 9.86 to get rid of the 9.86 beside it. This cancels, so I have sine theta is equal to, so now we calculate 3.5 divided by 9.86, and that will give me 0.35496, and it continues, but I'm just going to say 0.355. So I'm doing this to 3 decimal places. Now to get rid of sine, we have to carry it over. Once it goes over, we find the sine inverse. So I am going to find the sine inverse of 0.355. My angle here, when I find the sine inverse, that is equal to 20.79, and I'm just going to round it out to 21 degrees. So to find out the bearing of S from Q, I will have to add 41 plus 21 plus 90. And if you're wondering, where is it that I got these? Just a reminder, remember from here to here will be a 90 degrees angle. And from here to here will be 41 because it's Z angle. I had established that this is 41. So right here will also be 41. And we just calculated that theta here will be 21 degrees. So I add 21. So adding 90 plus 41 plus 21 degrees, that will give me 152 degrees. So what is this saying is that, remember this is 21 now. So all of this is 21. So adding all of these angle, the bearing of S from Q is 152 degrees. And just so that you have a clearer idea of what's happening, let me just get rid of these. So you're able to see properly. The bearing is from the North Pole going straight to this line, and it represents the angle, which is 152 degrees. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day. And if you have more questions, please leave a comment below.